In this presentation, we'll discuss some terminology often associated with physical level concepts, including the idea of partitioning, which is mentioned in Chapter 8. Some terminology you may have run across in your reading or may have heard in some of the resources that you've looked up are table space, segment, and extent. These are physical level concepts about how a database management system organizes the database therein. First, let's tackle the idea of a table space. A table space is nothing more than a named set of disk storage elements in which physical files for database tables may be stored. Within a table space, you have the concept of a segment. A segment is a database object that takes up physical space, such as a table or an index. Within a segment, you have the concept of an extent. An extent can be thought of as a chunk of data blocks. Within an extent, you have data blocks. Let's take a look at how these three things and others relate to one another. Here's a simple little diagram representing an Oracle database using some of the symbology that we've seen with entity relationship diagramming. If we think of an Oracle database as this monolithic thing, we can break it down. An Oracle database consists of many Oracle table spaces. These table spaces are stored in many operating system files and consist of many segments. Each segment, in turn, consists of many extents, and each extent, in turn, consists of many data blocks. You'll notice here on the bottom half of the diagram you see some symbology representative of supertype and subtype relationships. This is because each Oracle table space can be one of two types: what we call a special Oracle table space, which can further be broken down into the ideas of a system table space, an undo table space, or a temporary table space, or a user data table space. Likewise, a segment can further be broken down into three types: a data segment, an index segment, and a temporary segment. Take a moment to examine this diagram and just get a feel for how a database is broken down into pieces. Here's an SQL example for how to create a table space. All major relational database management system vendors have a create table space command in their SQL processor. This example here comes from Oracle. We create a table space by giving it a name, specifying a data file, specifying an initial size, in this case 50 megabytes, talking about how extents will be managed. In this case we say local, which means they'll be managed within the table space, and providing a uniform size for new extents, in this case 128K. One concept mentioned in the textbook is this idea of partitioning. Sometimes we think of that as denormalization. It's a bit more complex than that, but let's examine it a little bit. When we talk about partitioning, what we're talking about doing is breaking something apart, specifically a table, either by rows, what we call horizontal partitioning, or by columns, which we call vertical partitioning. Partitioning can be explicit or transparent depending on the method used, and it's helpful in a variety of situations to help with access speed. It's sometimes helpful for certain data warehouses and other databases where updates are an infrequent occurrence, though this is not the only location in which partitioning can be helpful. So, advantages and disadvantages of partitioning. Advantages include security and the ability to make even a simple table more secure by separating access rights for different rows. Load balancing, by spreading a table, for example, across multiple systems, you can improve how data is distributed within a large database. And efficiency. It helps to isolate different parts of a table, for example, and make it a little more efficient in terms of how the data is managed. Some disadvantages: by spreading a table, for example, across multiple systems, you may have inconsistent access speed. Programmatically, it's complex, meaning that application programmers may have more complex code necessary to bring together the different partitions. And update speed is sometimes challenged, given that data in a particular table may be spread across multiple systems. So what's vertical partitioning? Let's delve into that a little bit more. Often when we think of vertical partitioning, people think of normalization. The idea of splitting a table into several separate physical tables by separating the columns. When you do this, you repeat the primary key in each of the separate physical tables. You just happen to take one large table and split it apart. And join can be used to bring these columns back together. And this is kind of the idea with normalization. Taking something large with a lot of data redundancy and breaking it down into smaller tables, each of which have something in common. Horizontal partitioning is where we implement a logical table as multiple physical tables. Each table will have the same columns, but the partition can be based on values in one column or some other criteria, such as dates. You can think of this as somewhat similar to creating a supertype-subtype relationship. However, horizontal partitioning is not usually explicit to the end user. It still appears to the end user as one table, even though physically it may be implemented as multiple tables. Here's an example of horizontal partitioning using SQL. In this particular example, we're creating a table called book. Now, book has three columns: book ID, book name, and cost. After the create table statement would normally end with a closing parenthesis, we have a different clause immediately following called partition by range. What this is telling the SQL processor to do is to create this table book as actually three separate partitions. Meaning we have three copies of the same table, and we're actually separating the data as it comes in into one of three partitions. Partition book underscore P1 will store all those records whose book ID has a value less than 100. Partition book P2 will store all those book records whose book ID value is between 100 and 399. Partition book P3 will then store all the rest. Max value in this concept means the maximum allowable integer. It's kind of like a catch-all. So really what we're doing here is creating a single table called book, at least that's how the end user will see it. But under the covers, at the physical level, we're actually creating three copies of the table book and separating the rows into those three tables, or three buckets as you might call it, and throwing different records into those buckets. This is designed to gain efficiency for one reason or another, depending on the data set, but it can be a powerful tool. That said, it can also be a complex tool, so use it with caution.